Hello, today we are going to talk about bivariate distribution or joint distribution of two random variables. So suppose we have two random variable height and weight. We have data on both simultaneously. For each individual, I am collecting data on height and weight, and together, so the data will look like pairs of real numbers. And so these are points on xy plane, and so this is called the joint distribution of two random variables x and y. Now, so far what you have studied are one random variable. You have one random variable and their probability distribution. So values of those one random variable are real numbers. So you are fitting a probability distribution on the real line. But here we are talking about probability distributions on the xy plane. And now they are extremely useful and necessary because often we study a cause and effect kind of situation. So this will further lead to something called conditional distribution and conditional expectation. Now that is something that gives that is very important before we study our final topic, that is the regression. And so any course in probability is perhaps incomplete unless we talk and we know something about the joint distributions. Joint distribution there can be more than two random variables, but let us understand it with two random variables. It will be easy. Then the idea similarly extend to n many random variables. Okay. So I have got two random variables on a probability space. So x, y, if we write them as a pair, it is called a two-dimensional random variable, and it will be taking values in R2, that is in the xy plane. Okay, so now when we talk about joint probability distribution, so we refer to the probabilities that xy belong to some subset of the xy plane. Borel to Ethia you can ignore in this MS 451 course. It is slightly mathematical concept. This is for more technical correctness. কিন্তু তুমি ধৰি লব পাৰা যে C is some reasonable subset of the R2. XY plane of that subset লৈছো. So probability XY in C, that probability is called the joint probability distribution. So examples তোমার দিয়া হইছে ইয়াত C is all those points in the XY plane above the 45-degree line. It above hobo ne below hobo? This will be below, right? কারণ x coordinate is more than the y coordinate. Then these are the points on the 45-degree line. Then more commonly আমি এনেকা ধরনের frequently sound where C is the Cartesian product of two intervals. So when C is the Cartesian product of two intervals or two sets in general, তেতিয়া what is xy in C? That means x in A and y in B. This is the type of actually probability statements that we are more concerned more in practice. Suppose height of an, so you want to know what is the chance that height of an male of a certain age group in a population is between 5.6 to 6 feet and weight is between, let us say, 70 kg to 80 kg. And so then it was. So what is the probability or what is the frequency? So that will give us. So these are the kind of probability that are mainly concerned in joint distribution. And comma likhisu, that actually is the intersection. This technically means intersection of two events. One event is that x is in A, the other event is that x is in B. They are same events because x and y both are random variable on the same probability space. Okay. So আমি যদি individually only look at this probability x equal to A and probability x equal to B, these are called marginal probabilities. So এতিয়ালৈকে আমি যিবিলাক probability distribution দেখিছো, one dimensional probability distribution, that is probability distribution of one random variable, those are actually marginal probability distributions. So eta kotha holche, if you know the joint distribution, that is if you know probability x in A, y in B for all choices of A and B, from there I can easily get the marginal probabilities. Why? Simply I will take all values of y. So y b type you put r, then that becomes the probability x equal to x in A. Similarly, marginal probability of y in B is the joint probability where you are considering all possible values of x. So here is a question, jodi x is in r, y is in a hoy tene hole ki hobo? That is something not very difficult. See, both random variables are on the same space mapping from S going to r cross r. So basically you are saying that you are considering all values of x and y. So it should be all points in the domain. So that should be 1. And similarly, what is x in A and y in phi? So you have to ask yourself what is the, you know this comma means intersection. So what is the probability of A intersection phi, where phi is any event? So where A is any event, phi is the null set. So these are the answers. So here I will summarize that if we know a probability x in A and y in B for all choices of AB, then we can get the marginal probabilities যেটো মই কলো. And however, in general, যদি I give you all the marginal probabilities, from there we cannot construct the joint probability distribution. So joint probability distribution to দিয়া থাকলে we can find out the marginal probability. Simply you sum over or integrate over all values of the other variable. কিন্তু যদি joint probability distribution মই যদি x is also following, suppose I tell you that x is following binomial distribution, y is also following binomial distribution. What is the joint distribution of x and y? That we don't know. The only exception is that normal distribution, when x and y is normal, then the vector xy follows something called bivariate normal distribution. That is something we will come. কিন্তু even then that all marginal distributions you cannot find out the joint distribution. So first let us go back to the concept of independence of two random variables. So we know independence of two sets A and B are independent if probability of A intersection B is probability of A into probability of B. So the same idea is extended that if x and y are two independent, if probability of x in A and y in B is the product of probability of x in A and y in B for any two sets A and B. Now here the moi eta addition korim. So this also means a to proof is technical, so let's not bother about the proof. Gx into hy must be equal to expectation of gx into hy. A to all equivalent condition for every choice of measure real valued function g real valued. ইয়াত মই এটা কথা লিখিম, হেতু is a bit technical, that you need not worry at this stage. Measurable functions g and h. So you take all possible functions that you can imagine g and h. So expectation of gx into expectation of gx into hy should be product of the expectations, and that means x and y are independent. Now in particular jodi tumi g equal to gy equal to y loa, hy equal to y loa, then you get expectation of xy is equal to expectation of x into expectation of y, but that is for only one particular choice of g. So if x and y are independent, and y are independent and y are independent, then expectation of xy is expectation of x into expectation of y, but the converse is not true. এটোর এক্সাম্পল আমি অলরেডি কোভেরিয়েন্স ও নোটস দেখিছো, converse not true. তার মানে এই2 হলে অকল, if you say that I have only this condition, that does not imply independence. It means they are not correlated. Okay, if they are independent, they are not correlated, but uncorrelated হলেও dependent হতে পারে. We have seen an example, x takes -1 plus 1 with probability half, y equal to x square. So now joint distribution bolile ami ki bujhao, ami moi kolu by joint distribution we mean all possible probabilities x in a, y in b. Now in particular, suppose x and y are two discrete random variables, then by joint probability distribution we would need probability x equal to x, y equal to y for every choice of x and y. So all possible values of x and y loa are all possible combinations loa probability x equal to x, y equal to y, that is called the joint PMF or the joint probability mass function. ठीक है, then how do you find probability that xy is in some subset on the real line? Suppose you want to find the probability that x is in the interval AB and y is in the interval CD, then you sum over all values of x and y which satisfy this condition. That means in this case x is between A, you find all values of x between A and B, find values of all values of y between C and D and sum them up. Now in particular, if x and y are continuous random variables with continuous random variable hole what will be this value? if x and y are continuous. Remember, continuous random variable mane ki probability x equal to x is 0. So continuous random variable hole these probabilities will be all 0. So we cannot find probabilities in that way. So in that case, suppose f is a non-negative valued function. In this case, function of two variables which integrates to 1. Then we can define call it the density function. In this case, we will call the joint density function. Joint density function. And now the difference is that the density function is a function of two variables. And how do we compute the probability? We compute the probability by computing the integral with respect to x and y, where x is and y satisfy the condition in C. Okay. So for instance, suppose I want to find the probability x is less than y. Tenehole ki hobo? Tenehole we will be integrating over all values of y, but then we will restrict the integration of x from minus infinity to up to y. A2 hobo tetia I want to find probability when x and y are two continuous random variables. So yeah, this will be what it is. So it was my example dilu teneka tumaloke bhabiba what will be probability x greater than y. Okay, so this is about joint distribution. So today I will not go to joint conditional distribution, rather mention and end with something called bivariate normal distribution. So A2 hobo definition to enekwa je x and y to normal random variables or random variables following normal distribution with mean mu1 mu1 mu2, which means mu1 mu2 and standard deviations so it's standard deviations sigma 1 sigma 2 respectively. Sigma 1 comma sigma 2 respectively. I may be running out of the time here because I cannot record more than 15 minutes. So let me tell you quickly. Sigma 1, then sigma 2 respectively, and rho is the correlation coefficient between x and y. Then the joint distribution of xy is bivariate normal, is said to follow bivariate. Bi means two, bivariate normal distribution with PDF আমি এতিয়া PDF এর ফর্মুলা টু লিখিম So where is this thing with the PDF? And